Hello, everybody. Welcome back. Today we're going to be looking at Unit 4.4, which is all about physical and chemical changes. We've already looked at that a little bit. We're just going to look at that topic in a little bit more detail today. So let's get started. So let's start off talking about, what is it that actually makes the difference on a chemical molecular level between a physical and a chemical process. And a physical change is typically going to involve the breaking and or forming of intermolecular forces. Okay, remember that term, we've seen it before. It means forces of attraction between molecules, not within. Okay, so some examples of that are any kind of phase change. Okay, if you melt a block of ice or anything like that, you boil a pot of water, you're not changing the chemical composition of these substances, you are simply changing the intermolecular forces. Whereas a chemical change involves the breaking and or forming not of intermolecular forces, but of actual chemical bonds. That could be covalent or ionic, right? Just to give you some examples, a nail, which is mostly made of iron, it rusts. That's a chemical change. You take bread dough and you bake it in the oven and now it's bread. There's actually multiple chemical changes that are going on there, but the point is that a chemical change is something that is irreversible. Bonds have been broken, new bonds have been formed, and some sort of new substance has been created. So people ask a lot, what about the dissolving process? And that can actually be argued both ways, all right? You could say that a situation like this is review, guys, where you've got a block of sodium chloride, table salt, and you put it into water. We have seen this kind of diagram before where the ions separate from each other and each ion is separated by sort of a cage of water molecules. So this image should be review for you. You could say that the process of dissolving is a chemical process because you are breaking those ionic bonds are being broken. So from that standpoint, you could say that it is a chemical process. However, you could say that it's a physical process because it is reversible. You can get every single last gram of salt that you dissolved, you can get it back by simply boiling off or evaporating the water. You didn't have to do anything, any chemical process to get that material back. So from that standpoint, you could defend it as a physical process. So really it's both. So let's look at a sample problem. It says, which of the following describes the changes in forces of attraction that occur as H2O changes phase from a liquid to a vapor? So I want you to pause the video and think about which one is going to be the answer. Okay, let's see how you did. B is going to be your answer. Okay, it's not going to be A, C, or D, okay, because all of those are talking about actual bonds being broken, okay? Letter E doesn't really even make sense. Covalent bonds become more effective. That doesn't even make sense. And actually, letter C doesn't really make a lot of sense either because what is existing between H2O molecules is not even covalent bonds. Now, just remember, guys, even though letter B says hydrogen bonds, remember that I put in my PowerPoint presentation, I put the word hydrogen, the word bond in quotation marks. Hydrogen bonding as an intermolecular force isn't really a bond. It's just a force of attraction. Okay, so this is definitely a physical change because we're going through a phase change, and intermolecular forces is what's being broken. All right, let's look at another one. This would be more in free response. A student sands the surface of a 6 centimeter strip of magnesium metal and places it into a crucible. The crucible and magnesium are masked, placed over a Bunsen burner, and heated strongly for 10 minutes. After cooling, the final mass of the crucible and combustion product are taken. The following data are collected. And there it is. There's our data table. What experimental evidence would best help the student confirm that a new compound has been made and that a chemical change has occurred? So pause the video and just think about it for a moment. How might you explain this? All right. To get credit for this question, you would absolutely need to reference the data table. And if you'll notice, the first mass to the second mass, the mass increased. All right. So this magnesium must have reacted with something. All right. There's a greater mass at the end than there was at the beginning. This magnesium must have reacted with some other substance to form a compound with a greater mass. If you remember what the word combustion means, it means that the magnesium reacted with O2, oxygen in the air, to create magnesium oxide, which it gained mass because it took in the mass of oxygen from the air. Now, you wouldn't have to say all of that, but you would at least need to say what is printed in yellow on the screen in front of you. So just some examples of kinds of questions that you could see in terms of chemical versus physical changes, and wanted to make sure that you all understood on an atomic molecular level what makes something a physical change versus a chemical change. So I hope you've learned a little something today, and I look forward to seeing you next time.